Good morning, everyone, and welcome to the lecture series on network and cybersecurity. I'm Raghavendra, Nagaralli, Assistant Professor of EC Department. So today we are going to discuss about the email security from the module number 2. So these are the contents covered in today's lecture. So in the email security, first the basic security protocol that we are going to discuss is the PGP, that is pretty good privacy, and today we are going to see the introduction to the PGP and the notations used for its operation, and the authentication only approach, that is the first service provided by the PGP. And from today's lecture, the students will have a better understanding of the basics of the email security protocol, the first protocol, that is pretty good privacy. Starting with the introduction, pretty good privacy or PGP was first created by the American cryptographer and the computer scientist or computer engineer Phil Zimmerman, and he has implemented this as a product for the email security purpose, and which was released in the 1991. And to do this algorithm or this protocol, he has followed few rules or steps. And the first one is he selected the best available cryptographic algorithms, which was widely accepted as a secure one, like SHA-1, IDR, Diffie-Hellman, RSA, DSS, DDoS, which were used for the basic various applications. And he selected all those available cryptographic algorithms, and he integrated these algorithms into a general purpose application for the email security. He integrated these highly secure algorithms which are used for the different applications, and he bundled them, and he made a package which will be directed towards one goal of the providing security for the email application. He made this package freely available via the internet. So this PGP protocol is not owned or not controlled or governed by any of the governments, any of the organizations, standard organizations. So he developed, Phil Zimmerman developed this protocol, and he made freely available via the internet in different versions, in different packages. And he also provided the low-cost commercial version of the PGP for different corporate sectors. He has developed different versions of the PGP, and he has also developed the versions for the personal use. And we have another standard email security protocol which are made standard for the commercial purpose. We will see about that later. We will discuss about that later, and that is the SMIME. PGP provides both confidentiality and authentication service that can be used for electronic mail and file storage applications. And this PGP has been widely accepted, and it is widely used because of many reasons. The first reason will be it is available freely worldwide, as we have already discussed, and that will run on a variety of platforms like Windows, Unix, Mac, and others. The second reason will be it is based on the algorithms that are widely popular and accepted as secure. RSA, DSS, Diffie-Hellman for the public key encryption, IDR, DDoS for symmetric encryption, and for hash coding it is using SHA-1 or SHA-1. The third reason will be wide range of applicability, and the fourth reason will be it is not developed or controlled by the government, as we have already seen in some of the symmetric algorithms and public key algorithms which are developed and controlled by some organizations like NSA, National Security Agency of the US. And these are the notations used. The session key used in the symmetric encryption, which is generated by the sender, and it is being transported or transferred to the receiver side during the handshaking procedure, which we already discussed. And the PRA and PUA, and these are the private key and the public key of the user A for the public key encryption. EPDP, these are the public key encryption and public key decryption algorithms. Similarly, ECBC, these are the symmetric encryption and decryption algorithms. Hash function, that is the SHA-1, SHA-1, concatenation symbol. Z is the compression, and the compression algorithm used in the PGP is the zip algorithm. And R64 is the conversion to the radix 64 of the ASCII format to provide the compatibility. The operation of the PGP consists of 4 services. These are the basic services that are required to provide the security. First one is the authentication, second confidentiality, third one the compression to reduce the size, and the email compatibility, so that it should be able to run on different platforms. So today we are going to discuss about the first one, the first service. Even though we need the combination of all these 4 services, but the first one we will see the authentication services. So here this diagram shows the authentication only approach. Here we are providing only the authentication, no any confidentiality, no the combination of both authentication and confidentiality. Here we have the sender side, here we have the receiver side or the destination side. In the source, the source generates the message, and after generating the message, he calculates the hash code of the original message using the SHA-1 to generate the 160-bit hash code, and that hash code is encrypted with the RSA algorithm using the sender's private key, and then that key is appended with the original message, and that original message is then compressed using the zip algorithm, and that is transferred to the receiver side. So this is the message received at the receiver side, which is in compressed, and which is the concatenation of the RSA algorithm, the key from the RSA algorithm, the output from the RSA algorithm, and the original message. And after receiving at the receiver side, the first we have to do to recover the original message is to unzip this using the Z inverse, the inverse of the zip algorithm. And then after the inverse, once we apply the inverse of the zip algorithm, we will get this concatenated message. So here we have the output of the RSA algorithm, and here we have the original message, which is in concatenated. So this part we take separately, and we apply the decryption, RSA decryption, using the public key of the user A, which is available to everyone. And here this private key is available only to the sender A, and this public key is available to everybody, publicly available. And this original message is taken, and the separate hash code is generated by the receiver side at the destination. So once we decrypt this here, we will get what? We will get the hash code, because the encryption is done on the hash value of the original message, which is generated by the sender side. So here, once we decrypt this, we will get the hash code which is generated by the sender side. And here separately the receiver is also generating the hash code which is received by him from the sender side. So then he is generating the separate hash code, and this is the hash code generated by the sender. The both are compared here. If they are same, the message is accepted as the authentic. If they are not same, it means that there is some changes happened during the transmission from the sender to the receiver. So this is how we are providing the authentication of the message, the originality of the message, to check whether it has been altered or not during the transmission from the sender to the receiver, by calculating the hash code separately at the receiver side and then comparing it with the hash code sent by the sender side. Okay, in the next class we will study about the confidentiality and the combination of both authentication and the confidentiality.